Okay, can you hear me all right? Yes? Okay, good. Hi, everybody. Welcome to the last talk for the day. And let's see what we have in front of us. It's a full-hour monologue on technical debt. I'm terribly sorry. Everyone's at NDC talking about their passions, and I'm afraid this is mine. Yeah. So my day job is working for NRK TV. NRK is the national public broadcaster in Norway. So basically, if you're a Norwegian and you're watching any of our NRK's productions using the internet, you're using one of our products. Yes. So what is technical debt? So I'm going to start a little bit philosophically, and then we're sort of going to just go on asking questions, coming up with some potential answers, and then just sort of going from there. So what is technical debt? And as sort of a backdrop for that discussion, I would like to consider technical debt as a meme. And when I say meme, I'm not talking about like these internet memes that we're all very familiar with, like funny pictures that are either original or not that original anymore. So not these internet memes, but the concept of memetics, which it's sort of a parallel to genetics. So it was proposed by Richard Dawkins in his book, The Selfish Gene, as sort of a similar mechanism to what's happening with genes, but at sort of the idea level. So the idea is that you have something called a meme, which is a self-replicating unit of thought. And this, just like memes are copied from person to person, the genes are copied from person to person, you have these memes that are copied from brain to brain. And that means that it has some of the same characteristics as you have for genes, that there is sort of a scarcity, there is variety, and the good ones, or the fit ones, survive, and the other ones don't. Richard Brody wrote a book called The Virus of the Mind, which deals with these memes. So then, what makes a meme successful? So what is the mechanism for survival of the fittest when it comes to ideas? And one sort of, I suppose, positive angle you could take is that the best ideas win, the ones that have the greatest explanation power. A very different take is to think that it is the ideas that are most effective at reducing cognitive dissonance, because we know that we don't like cognitive dissonance. It makes us feel bad. So in a sense, you have this tension between the best ideas and the ideas that makes us feel the best about ourselves. And I would like to have that thing as sort of a backdrop for this discussion about technical debt. So, what is technical debt? Does anyone know who this guy is? Ward Cunningham? He's done a lot of innovations. He's the father of the original wiki. He created CRC cards with Kent Beck. And he is also the man who came up with this metaphor called technical debt. And what he originally said was that shipping first-time code is like going into debt. A little debt speeds development as long as it's paid back promptly with a rewrite. And the danger occurs, so there is a danger, when the debt is not repaid. And every minute spent on not quite right code counts as interest on that debt. And this is quite dire, entire engineering organizations can be brought to standstill under the debt load of an unconsolidated implementation. So that's already quite a rich metaphor. And it's sort of been reduced, I think, in a lot of our minds into this single thing called technical debt, which is not as rich as this original metaphor. But OK, so what are sort of some of the good things about this metaphor? Why is it a good metaphor? Well, one of the reasons I think it's a very good metaphor is because it gives us language to talk about something that's important to us. And it helps us put quality on the agenda. Because one of the problems when you write code is that the code is invisible. So it's very hard for people who might have some interest in your code to sort of see the issues that they're talking about, unless you have some language to sort of convey that meaning. So for that, and for many other things, thank you to Ward Cunningham for this great metaphor. Now, on the flip side, what is sort of a problematic? What are the problematic aspects with this metaphor, technical debt? Well, one sort of obvious thing is that if you have like real monetary debt, it's easy to know how much you have. Right? You can ask your bank how much was it again, and they're going to say like it's 2 million, and you say okay. Technical debt is not that easily quantifiable. I know there are some efforts. So some people try to estimate how much technical debt they have, and they get some measure. I'm not sure it's really technical debt that they're measuring, but something they are certainly measuring. But it's hard to answer this question, how big is your technical debt? And there are even worse questions that you can ask. Are we even technically solvent? Is it possible to go technically bankrupt? Perhaps we've already gone technically bankrupt. What would that mean? And to answer these questions, we sort of have to dig deeper into what technical debt really is. And when you want to try to figure out what something is, you can try to say, okay, what does it look like? Is it ugly code? I've been a programmer, I think, for something like 15 years or something, at least for money. And I've seen some ugly code. Some of it might be technical debt, some might not be. Some of it makes me look like this when I read it. But that's not very helpful in some sense. So maybe a better angle is to sort of look at what causes technical debt. And if you ask a developer what causes technical debt, you can get some theories. So what is this, the mechanism that makes the code ugly? Is it a lack of time? Other people say, well, we have technical debt because of lack of time. And it sort of pays back to the original formulation of Ward Cunningham, so you can sort of speed up things for a little while by going into that. Or is it that the project manager doesn't understand me because it's not technical? Or is it that the user experience people are hopelessly unrealistic and they don't know sort of the cost of the features that they propose? Or I suppose this is perhaps the most common one. The previous developer was really stupid. Well, again, what does it look like? Well, we can argue about this, but at least to me, usually when I see something that's classified as technical debt, what I see is a heap of flags and branches and indirections. And it's sort of like this self-modifying roller coaster thing where you need to set the right flags at the right time so that you'll get through the right loop to achieve the result that you wanted. And it's in general very difficult to determine where something starts and where it ends. It's very hard to isolate something that is related to one single feature, and it's very difficult to predict the effects of changes. And in general, there's this problem that it's hard to reason about the code. It makes your head hurt. Now, these things, what do they indicate? Well, is it that the project owner doesn't understand technology? It doesn't seem right. Is it that the previous developer used the wrong framework for dependency injection? Or maybe that we should have microservices instead of the monolith? Or that we need a NoSQL database? Or we should go to serverless? Or that we should move everything to Kubernetes? And these are all sort of like technical solutions to some problems, but I'm not sure if they're solutions to this problem. So that was supposed to be rhetorical questions. So hopefully it's obvious that no, this does not answer this question. But it is also obvious that there is something that has gone very wrong. And it's something that has gone wrong in the process of capturing the business domain in software, which is what we're trying to do. And it's something that's gone wrong in understanding the business domain itself and making and enforcing decisions and finding some suitable representation of your business domain in software. And what's more is we have a word for this process. And it's called modeling. And it's a very sort of like old school 80s sounding thing, but that's what it is. It is modeling that has failed. And as long as we're naming things, what's the name of the tool we use to contain and conquer complexity in our code? We have a word for that as well. It's called abstraction. Now, unfortunately, abstraction is a sort of two-edged sword. So it also happens to be the name of the tool we use to create and compound complexity. That's abstraction too, if we do it the wrong way. So, at least one perspective is that modeling is the application of abstraction to a problem domain. But at the same time, modeling is also defining what the problem domain should be. And I just have to say this because modeling, I suppose, has been given a bad name because of all these sort of monster efforts up front, sort of try to model everything down to the class implementation detail before you start sort of doing any implementation. So that's not what I'm talking about. I'm talking about continuously working to understand and better articulate the problem you're trying to solve. And it's not just me saying it. This is back to Ward Cunningham. He said that you're wise to make the software reflect your understanding as best you can. So this technical debt metaphor is not an excuse not to do modeling. Well, so that's one part. One thing that's often sort of not talked about when talking about technical debt is how do we pay it off? How do we sort of get rid of it? Well, we do have an answer for that. Everyone knows how to sort of pay back technical debt, and that's refactoring. We can just refactor it away. Now, there are some refactorings, but it's not so easy to sort of get at what refactoring you should use when what you have is a tangled mess of weak abstractions. So basically, this is the catalog of refactorings at refactoring.com. And they're all very low level. They're all very close to the code. And it's not obvious how push-down method is going to help you sort of solve your problem with weak abstractions. And this is, I think, a very good quote by Sarah May. She said that a rewrite will end up with the same problems as the original one unless you close the understanding gap. So what's the understanding gap? Well, in some sense, there is little purpose in doing refactorings if you're not at the same time doing remodeling. So you have to have some sort of goal which is model-driven to where you're going with your refactoring. I mean, you can do sort of small things without remodeling, but for sort of handling this sort of like larger improvements to the abstractions in your code, these low-level refactorings is not going to do you very much good. And I think really that anything else is just hubris on the part of us developers. So we have this tendency, I think, in the industry to think that if we are just sort of virtuous enough, if we follow the best practices well enough, if we read all the latest blog posts, we do all the correct practices, then these problems will go away. But I think reality is more like this. So you start out well, but then you sort of hit the brick wall. And these best practices are not enough. And unfortunately, it would be very nice if sort of these generic practices would be sufficient to save your code. But they will not save you if you have a rotten model, if your understanding of the business domain is insufficient. How are you going to sort of build the correct abstractions to make the software workable and viable? In fact, doing that, trying to sort of take this code base that's sort of sucked down in technical debt and try to refactoring without doing the remodeling first, you will just waste time and money. So you need to fix your model first, you need to fix your understanding first, and then you can fix the code. And I'm not saying that these practices are bad. I'm saying they're just not as sufficient, right? So let's see where we are. Well, we're not done. It's just been 15 minutes, so there has to be more left. Well, okay, so I said to fix this problem with technical debt, we first have to fix the model. Well, how do we fix the model? What causes modeling debt? And now we're sort of back at square one in some sense. And this is just the start of another sort of journey down, trying to understand what these issues really are. So, but before we do that, I'd like to tell you a small story. So this is the story of a fictional software company called eQuest. And eQuest delivers a suite of products for the horse owner. So there's a breeding module, there's a transportation module, there's a feeding module, anything that you need to sort of be a professional in the horse industry, whatever that is. So you typically work with entities like this. And for some reason, this company, eQuest, is a great success, and it's expanding. So one day your product owner comes and says, oh, we're going to use this, we're going to have this new horse as well. And it looks like this. And they say these horses are very strong, and they're stubborn. So we'd like to sort of have this as part of our software. And it's quite easy to talk about this because in the design meetings, everyone understands what you mean when you say this short, strong, and stubborn horse. But it's a little bit harder now that you have this new kind of horse. It's a little bit harder to understand what people mean when they say horse. Because sometimes they mean horse, like this horse, and sometimes they mean the horse and the new horse. And for this reason, people start to invent sort of qualifications, like this is a regular horse, this is a typical horse, or a true horse even, an old-fashioned horse, or even a horse. But that's fine. So you sort of add some properties to your code. If the horse is short and it is stubborn, then you have the logic for this new kind of horse. And if it's not, then you have the regular horse. And everything is fine. A lot of you reuse. You go into production quite soon. Everyone's happy. But of course, there are bugs. Now, why are there bugs? Well, it's the stupid users, right? Because some users have horses that are short, and they think also that their horses are quite stubborn. So they sort of tick this, oh yeah, it's a stubborn horse. And then suddenly they got for their regular horse, they get the new horse logic, and they didn't want that. So that's a bug. And so you call the design meeting, and it turns out that this new short and stubborn horse, they also say "iha." So that's something you can rely on, because the other horses sort of regularly neigh, but these horses say "iha." So you can sort of fix your logic like that. And now this goes into production. The bug fix is into production. Everyone's happy. In fact, they are so happy that the product owner says, oh, you're going to have yet another kind of horse. This is a new horse. And then you as a developer, you say, okay, what are the properties of this horse? Well, it's a kind of horse that is the offspring of a regular horse and a short and stubborn horse that goes "iha." It's quite simple. In fact, it has so many properties similar to both the regular horses and the other horses that you could reuse a lot of the code. Of course, your logic looks a little bit worse now. And about this time is when you start to say to your product owner, we have some technical debt in the code. Now, unsurprisingly, there are bugs, which is kind of a disappointment because you worked quite hard to work out that logic. But it turns out that it matters for some reason, for some of the code in some of the modules, whether or not it is the mother or the father that is stubborn and strong and goes "iha." Because it turns out that only one of those combinations can have offspring. So that's very important for breeding. And you're not so happy at this point. And then sort of, it goes on and on. There are still new horses. Yeah. As an aside, this sort of example is very simplified. right? So it's sort of, it jumps out at you what the concept should be. And what is problematic with that story is that it indicates that there is an answer to that question. What are the concepts we should use? So everything would work out if we would just work out that, okay, there is something called a donkey, there is something called a mule, and stuff like that. But I recommend reading this article called What If Anything is a Zebra, which goes into some detail in discussion whether or not there is sort of this, we all know what a zebra is, like it's a striped horse, but is it really, is it sort of just one group of horses, or, well, it's not horses, it's zebras, but sort of, is it the same group at the sort of DNA level? Is it just one kind of thing, or are there sort of horses in between the different kinds of zebras there are? Because there's just not one kind of zebra, there are 3 kinds of zebras. So is there one conceptual group called a zebra? Very interesting. So important, there is no truth to being covered usually. They're just more or less useful models, and it's sort of up to us to figure out what the useful models are. And this means that modeling is just as much about defining what should be useful for us as sort of uncovering some truth out in the universe. As an example from that, I would like to talk about sort of my daily life at NRK TV. So what, if anything, is a TV show? This is something I think a lot about every day, basically. So here's a TV show, and this is a TV show of the kind that has sort of a long narrative that goes across multiple episodes, right? And it has sort of, well, it starts at, when you want to see it, you want to start at the first episode, and then you see the next one, and then you see the next one. If you see the last one first, you spoil everything. But not all TV shows are like this. This is a TV show of documentaries, so you can watch any episode independently, that's fine. And here's another kind of TV show, which tells the daily news. And usually you don't binge the daily news, right? You're interested in the last one. And that matters when we sort of want to present it to the end user. And this is the kind of TV show, again, usually you want to see the last one. This is a sort of a talk show where the host has some guests. And you might want to see the last one, or you might want to see the one that features someone you find interesting. But it gets worse, because, well, this is, for the non-Norwegians, this is Scum, which is basically our most popular TV show, at least for on-demand TV. And it's not just video, right? It's these online sort of social media kind of things. So there are things happening on a web page. Sometimes it's video, sometimes it's something else. And it sort of challenges the entire idea of what a TV show is. In fact, we have this projection from this into a more traditional form with sort of these half-hour episodes that go consecutively, so that it resembles a usual TV show. But it's an interesting thing, because what often counts as creativity is challenging the mental models you already have of what something is. So answering this question is very hard. Well, how many kinds of TV shows are there? Well, which concept should we use? How can we enable ourselves to talk precisely, and how can we sort of know that we're not in the position that eQuest was in? And it depends on what we want to express. And quite frankly, the truth is that modeling is hard. And it's hard for 2 reasons. And the first is the stuff that's being modeled, and the second is those doing the modeling. Yeah, and we'll look at each in turn. So first, let's look at the stuff that's being modeled. Why is that hard? Why is that so hard? Well, in some sense, reality has no interest in being modeled. Really, reality just is, right? So it's not tidy and organized. It's not even consistent. It tends to be messy, and it slips away. It doesn't want to be contained. And what we're trying to do when we're modeling is impose some structure on something that's sort of fundamentally unstructured. And I recommend this book. It's from the 70s, I think, called Data and Reality by William Kent. And it talks about some things that makes sort of reality hard to turn into data. And one thing is identity. So what does it mean for something to be one thing? And there are lots of examples like that. An obvious example is like a book. Is my copy of a book the same as your copy of a book, or is it sort of some abstract notion of a book that encapsulates all the concrete books that are out there? So what's one thing? And it depends again, right? Another thing is what is equality? What does it mean that two things are equal? When are they the same? And is being equal and the same thing? It's terribly sort of philosophical thing to think about. And also change is interesting. So if some things change, when do some things that you previously considered to be equal become different from each other? And finally, how do we categorize things? How do we determine which category something belongs to? Is it possible for a thing to change category? And is that event of changing category so significant that it means that it's become another thing? So if those things are interesting to you, I recommend reading that book. Another book I recommend is one that's called Women, Fire, and Dangerous Things by George Lakoff. And that talks more about categorization. Now, the classical theory of categorization is based on properties. And as sort of object-oriented programmers, we're all familiar with this theory of classification because that's sort of the underlying idea behind classes in languages like Simula that we saw this morning and C#. And basically what it says is that you have some properties that are necessary and sufficient to determine whether something is a member of a category. Now, what does a bird look like? Can you sort of picture a bird in your head? Just try to, okay, a bird. Just conjure it up in your head. I'm sure you can do it. Did anyone think of this bird? Yes, there's one who thought about that bird. How many thought about something like this? There are more who thought about something like this. Who thought about this one? There is one who thought of a shoebill. That's perfect. It's one of my favorite birds. Now, the idea by this thought experiment is that there are some members that can be thought of as more typical than others while being members of the same category. So in some sense, a sparrow is more birdie than a penguin. And a sparrow is also more birdie than a shoebill. Now, you could argue that, okay, but a sparrow is more birdie than a penguin because a penguin doesn't fly. Well, a shoebill flies, but a sparrow is more common, so that's why we sort of think of that first. And in fact, I was having a discussion about this, and I think a sparrow is probably the birdiest bird that there is. And this is one of the topics in this book by George Lakoff, and it has to do with something called prototype theory that was introduced by Eleanor Roche in the 70s. And I'm quite convinced, now, you've heard about classical inheritance, and you've heard about prototypical inheritance in languages like JavaScript and Self. And I'm quite convinced that Dave Unger was aware of the work by Eleanor Roche. And that's why they have prototype-based inheritance in Self, and that's why you have it in JavaScript. But it's interesting to think about how untypical is too untypical to be a member of a category. When is it too unequal? When does the donkey become a donkey? Well, it depends again. And certainly the donkey doesn't care. It just is whatever it is, right? It's a horse, it's a donkey, it's just something. So we are the ones who are trying to put things into categories to make sense of reality. And this also means that generalization is a hypothesis about the future. So if you sort of create a category for things, you're saying at the same time, I'm expecting things to have a certain set of properties also in the future. And that's why you should be very, very careful by introducing artificial ad hoc generalizations, because you're betting against the future, right? And if someone's being creative, like creating a new kind of TV show in our case, it might be that your bet was wrong and you lose. So the second thing, why modeling is hard, it's those doing the modeling. So the reality is, it doesn't want to be modeled. Now, who makes software? And that's at the same time asking the question, who owns the technical debt? And it's easy for us as developers to say, well, I'm the one typing the code, so I must be the one making the software. And of course, the rest of the organization would dearly love it for it to be the case that technical debt is something that the developers or the IT department owns, and they don't really have to care about it. But at the same time, it's kind of hard to ignore that the fact that the organization is a part of the culture that produces the software, because they sort of create the framework that the software is written in. And this is an excellent quote by a friend of mine who says that if you remake awful software from scratch without changing the culture that created it, you will remake awful software. Now, when discussing how organization affects software, you often hear people talk about Conway's law. Who's heard of Conway's law? Everyone, or maybe not everyone, but at least quite a few of you. Well, it's an interesting exercise to sort of go and read the actual paper to see what he meant. So I recommend reading How to Commit This Event by Mel Conway. I think it's just like 4 or 5 pages. It's not long. And it's quite well written. And it says some interesting things. One thing he says is that just by organizing a team to solve some design problem, you have already made some design decisions. Because there are some there will be some design options that cannot be effectively pursued by the team that you assembled. And given this, it's a very interesting question how agile the organization is. Will the organization or the team that you set out to solve a task be agile enough to modify itself so that it could solve the task better? Is it able to identify that it's not the optimal organization to solve a problem, sort of dissolve itself and then reform in a shape that's more suited to solve the problem? That's quite hard. And the second thing is what's known as Conway's law, but that Conway calls the homomorphism, which is a fancy word. And the question he asks is there a relationship between the structure of the organization and the structure of the system that it designs? And Conway's answer is yes, there is. And in fact, it's a very, very simple relationship. It says that an organization tends to produce self-portraits in the system that they create. It means that if you have an organization that consists of 3 teams, you're going to have a system that has 3 sort of modules, right? 1 for each team. So it looks just, if you draw a graph of the software, it's going to be 1-to-1 with the organization that produced it. And for that reason, some people who want to change the architecture of the system figure out that, okay, we're going to try to change the organization to fit the architecture that we want for our system. And that can be a good idea, but it's very, very hard to do in practice. Because, well, organizations don't want to change, and also systems don't want to change. So you have to work very hard at it. And for this reason, Matthias has this corollary to Conway's law that says that if you design a system, but you didn't design the organization to produce the system, then you're not the systems designer. You might think that you are, but if someone else determines the structure of the organization, you are not the system designer. So all this points to the divide between business and IT as very, very problematic. And in some sense, Conway's law implies that system architecture is enterprise architecture and the other way around. Okay. So, well, we've certainly come a very long way from ugly code. And it might be worthwhile asking, why do we still talk about technical debt? Because these things that we've been talking about now, they're not technical at all. Well, one thing is that the consequences of all these sort of issues are made manifest and they're visible at the technical level. That's where you have to see them. And it's also this thing that we as developers have this tendency to sort of look for technical solutions, even to soft problems. One thing is that we might not be aware of the soft problems that influence us, and then we sort of reach for the solutions that we know about. But it's also that the soft problems are really hard problems. Are probably the hardest problems there are. And technical tasks, they are very tempting. And they're tempting because sort of that's what we signed up to do, right? It fits what we've been trained to do. It fits what we're good at. And they involve little in terms of sort of psychology and politics. And they rarely lead to conflict. I mean, we can argue over what library is the best or what technology is the best or something like that, but it's not that kind of conflict. And technical work is puzzle solving, whereas modeling work tends to reveal tensions and conflict between people and perhaps between different parts of the organization, things that might be very hard to resolve. And in some sense, if you take Conway's laws seriously, you might have to reorganize in order to be able to do sort of the appropriate refactoring that you should do. And that might not be in your power to decide, right? Now, let's return to this question that we had. What makes a meme successful? Is it the greatest explanation power? Or is it the idea that is most effective at reducing cognitive dissonance? It would be very nice if technical debt were technical, because then we could solve it, and we didn't have to rely on other people to help us solve it. But I don't think there are any technical solutions to technical debt, unfortunately, and the reason is that technical debt isn't technical. And that's all I have. Thank you. Are there any questions? Yes, there is one question.
So what should we call it?
What we should call technical debt? That's a very good question. And in some sense, what I want to sort of do in this talk is to point at some things we discuss too little with respect to technical debt. And I suppose you could say that some technical debt really is technical, and it has to be like, okay, it's an obsolete library, or someone actually wrote crap code when they should have been able to do a better job and stuff like that. So it sort of is a little bit of a hyperbole. Hyperbole? Is that how you say it? Yeah, well, exaggeration perhaps, to say that it's not technical at all. But I think at least we should be talking about modeling debt, and we should be talking about the consequences of sort of working with an implementation where we don't really understand the problem that we're solving. Well, yeah. Yes, another question.
Then